Summarize a little bit here after that little activity, okay? So let's summarize kind of what we talked about then. So if two polygons are similar, okay, then the ratio of their perimeters, all right, okay, so again, if two polygons are similar, then the ratio of their perimeters is equal to the ratio of the corresponding sides. So the scale factor, right? The scale factor there. The scale factor for the sides is the same as the scale factor for the perimeter. In summary. Okay, it's maybe easier to see it that way. Okay? So that's the first thing we looked at, right? But then we also talked about if two polygons are similar, then the ratio of their areas is equal to the square of the ratio of the corresponding sides. Right? That's what we talked about before, okay? Shannon correctly pointed out that, you know, in a basic shape like a rectangle, right, each, the length and the width are both getting multiplied by, you know, the scale factor, and so then when those new lengths and new widths get multiplied together, the scale factor gets multiplied by itself, so it makes it squared. Okay, K, you know, the scale factor K, we can say, is squared. So if it's like scale factor is 3, it's going to be 3 times 3 times the L times the W, which makes it 9LW. Okay. So again, if you want to say that, you could say the scale factor for the area is equal to the scale factor of the sides, put big parentheses around that and square it like that. So when someone tells you to double something, that really can, you know, there's some misinterpretation that could happen here, you know. When you're asked to double something, it's like, well, do you mean to double the sides? Do you mean to double the amount of area it takes up? Because if I wanted to double its area, that's not the same thing as doubling the sides, right? If I double the sides, I'm going to quadruple the area. Or if I want to double the volume, again, that would not be the same thing as then just doubling the sides, right? So you have to like adjust what you have to like get some more clarification about. When you say double this, what do you mean by that? Okay, you're talking about the volume, you're talking about the area, you're talking about the size, because that's going to change what you have to do then. Okay. So questions on any of that? Those are like our two big ideas. That we're going to look at some examples. All right. So just as a quick example here, let's do it in a little example. So let's say the perimeter, okay, of, you know, A, B, C, D, whatever shape that might be, is 54 meters. If if ABCD is similar to EFGH, and the scale factor of A, B, C, D to E, F, G, H is 3/4. What is the perimeter of E, F, G, H? So the perimeter of ABCD is 54 meters. If ABCD is similar to EFGH, and the scale factor of ABCD to EFGH, that means the top number, okay, what does that go with? Does that match up with the ABCD, or does that match up to EFGH? If it's ABCD to EFGH, the 3 matches up with ABCD or EFGH? So it's actually the other way around, and I know that's weird because we want to say, oh, this is the original and this is the image, but we're not. This is not necessarily a dilation here. We're just talking about similarity. So the ratio is this to this, and so the ratio here is this to this, 3 to 4. So A to ABCD to EFGH is 3 to 4. So the 3 is with this, the 4 is with this. Okay. So I know it's weird because we just talked about dilations, we talked about image over original, so we might think that this is the image because it's like the second thing, and this is the original because it's like the first thing. I get that, but this is not talking about dilations, this is just talking about similarity. And so it's this to this, so that means 3 to 4, 3 goes to the ABCD, 4 goes to the EFGH. So how can we go about solving this? Hunter, what do you say here? Any ideas about how we can go about setting this up? You had 54 times 0.75? Okay, how'd you know to multiply those things?
I don't know, I just times it.
It's just like, I should probably times here.
Yeah.
Okay, so when we're talking about similarity, I'm not saying you're wrong, but when we're talking about similarity, one thing we can do is set up like ratios, right? So, for example, if the perimeter of ABCD is 54 meters, so I'm going to say like, okay, 54... and then I want to find the perimeter of EFGH. I don't know what to call it, X. And that's equal to then the scale factor of 3 over 4, right? The ratios of the scale factor for the two shapes should also be the scale factor of the perimeters. So the scale factor for the sides, 3/4, should also be the scale factor for the perimeters. So you can set it up this way. Okay. And so when we cross multiply and solve here, let's see, you get 3x equals 216. Yep. Okay, divide both sides by 3. You get x equals 72. And what did you say you got there, Hunter?
Yeah, it's lower than that.
Oh, okay. Okay. So I think you yeah. I think you did the reciprocal of what you should have done. Instead of multiplying by 3/4, I think you should have divided by 3/4 there. Okay, I'll push it up. Yep, sorry, thank you. Okay, so 72 is what we would then expect the EFGH shape, its perimeter, 72 meters, I should say. We would expect its perimeter to be that. Okay, just by setting up that ratio there. All right, questions on that? All right, let's try another one here. So, question. Set this ratio here, proportion. So ABCD has a perimeter of 54, and we know that the scale factor, so that means like the ratio of the sides of ABCD to EFGH is 3 to 4. So 3 on top, 4 on the bottom. The 3 matches up with the ABCD, so that should match up in the same position as the 54, which is the perimeter for ABCD. Following that? So 54 over X, the unknown perimeter of EFGH. And you just cross multiply and solve once you got the set it up there. Okay? All right. So let's look at another one here. Let's say the area of IJKL is 152 centimeters squared. Okay. If IJKL is similar to MNOP, and the scale factor of IJKL to MNOP is 2/5. Whoops, I said 2/5 and I wrote 2/3. 2/5. What is the area of MNOP? So let's see here. We're talking about area now. So IJKL is 152 centimeters squared, and we're going to divide that by the unknown. We don't know put that in ratio with the other area we don't know, triangle MNOP's area. So 152 over x. And we want to say, okay, that should equal, and we want to say that should equal 2/5, right? Right, it's not equal to 2/5. It should equal 2/5 squared, which is what? What's 2/5 squared?
4/25.
Okay.
4/25.
Yeah, 4, 2 squared over 5 squared, 25. 4/25. Okay, 4/25. Okay, this is key. It said we want the area, so that means we have to take our scale factor there and square it. Okay, that's why we have to set it up like that. So then you cross multiply here. So 25 times 152 is 3,800. That's equal to 4x. Divide both sides by 4. You get x is then 950. 950 what? Centimeters squared, because we're talking about an area here, so it should be square centimeters. Okay? Questions on any of that? All right, then I think we'll stop there and I'll give you guys your assignments. You can start it on your homework, okay? I think that should be good. We'll see.